Hey everybody, this is Mrs. Hunsucker. We're only covering one section today for Monday, August 19th, and it's section 107 on rotations. I want to make you aware of 3 different learning targets. I can describe the rotations that map a given polygon onto itself. For example, you are going to tell me that I can rotate it counterclockwise 80 degrees, 90 degrees, 170 degrees. I can determine a figure's angle of rotation, anything between 0 degrees and 360 degrees. Rotational symmetry refers to the ability of the figure to map onto itself between 0 and 360 degrees. All right, we have our calendar for today, and this week we're covering 107 for today, August 19th. And if you notice, we only have 2 other sections that we're covering this week, section 108 and 109. Last week, if you remember, we had 6 sections. So make sure you enjoy this week with a lighter workload. If you notice that whether you meet on Wednesday or Thursday, there's no new instruction. If you meet with me on either one of those days, it will be a help session or a work session. You can work on assignments for Unit 1. I can also answer any questions you may have. And just to give you a heads up, if you notice, our lesson on Friday will be a Unit 1 review, and we're going to take the Unit 1 test. All right. So we're going to talk about lines of symmetry. We're going to divide each line. We're going to divide these 360 by the number of lines of symmetry that a figure has. And that answer will give you the angle of rotation. So your learning target was you describe an angle of rotation. And that's how you do it. You get a figure, you draw a figure, you draw the number of lines of symmetry in there, and you divide 360 by the number of lines of symmetry, and that's your angle of rotation. So let me see if I can insert. All right, that won't do it. I apologize. Give me 1 second. All right. So, if you take a look at this figure, can this figure map onto itself between 0 and 360 degrees? So starting at the top right foot, what is the angle of rotation? From the top right foot to the middle foot. Well, it has 3 congruent, as long as they're congruent, and you can take divide by 3. It's like a line of symmetry is a line that divide a figure. If we have 360 and divided by 3, which is 120 degrees. Also, it also has angles of rotation of 120 times 2. Okay, 120 times 2 is 240. And 120 times 3 brings us back to 360. So our angle of rotation are 0, 120, 40, and 360. So this figure has rotational symmetry. All right. So rotation is a rotational symmetry. A shape has rotational symmetry after some rotation. So we all have rotational symmetry. If you turn 360 degrees, one full turn. We're facing the camera. We map onto ourselves, so we have rotational symmetry. However, all figures have rotational symmetry of 360 degrees. We have this video. I'm not sure I'm going to be able to show that to you, so let's just move on. So what is the angle of rotation for this triangle? Once again, the line of symmetry is drawn. You may think there's 3 lines of symmetry, but we don't know that all sides are congruent. So the number of sides for a congruent figure, if a triangle has, or a figure has 3 congruent sides or 4 congruent sides, we can find the angle of rotation by taking 360 divided by 4, or 360 divided by the number of congruent sides. If it doesn't have congruent sides, then you're going to draw your lines of symmetry in. This particular figure, if you notice this triangle, the center rotation is that black dot. Okay, that's the fixed point. If you trace the triangle twice and on 2 different pieces of paper and put your finger right and made the vertices coincide, put your finger right on that black dot and only turn the top, when would this figure map onto itself? Okay, how many times would it map onto itself before it's in its original position? That would be called the angle of rotation. So for this figure, we have 1 line of symmetry. The sides are not congruent, so it's not going to be 360 divided by the number of congruent sides, but it's going to be 360 divided by the number of lines of symmetry. So this figure has rotational symmetry of 360 divided by 1 line of symmetry. So let me apologize, my voice is getting raspy. So our angle of rotation, all right, is equal to 360 degrees divided by the number of lines of symmetry. All right, that's one way you can find the angle of rotation. And remember, for this figure, it's 360 divided by 1. So the only angle of rotation that maps the figure onto itself is you have to make a full turn, 360 degree rotation. Now, if a figure rotates onto itself through 360 degrees, well, so do I. If I face the camera and I keep any object has a symmetry of 360 degrees. So we asked if 360 degrees guarantees because that is a angle of rotation. All right. How many lines of symmetry does the butterfly have? Well, it's drawn in. This butterfly will not map onto itself as you turn it. A fraction of 360 degrees has to turn 360 degrees before it maps onto itself. The angle of rotation is 360 degrees, yet it has no rotational symmetry. So let me go ahead and make a point of that. I'll type it on the board. Since this figure has only 1 line of symmetry, comma, the butterfly does not have rotational symmetry. Okay. The angle of rotation, remember, is 360 divided by the number of lines of symmetry. So the angle of rotation is 360 degrees. All right, and that's no rotational symmetry. All right, So if it only has rotational symmetry if it rotates onto itself between 0 and 360. So what is an angular rotation? Hopefully you're able to tell me that an angular rotation is the measurement of the amount of the angle by which a figure is rotated counterclockwise about a fixed point. So if I ask for angular rotations, I'm asking you to rotate counterclockwise. Let's see. And about a fixed point, like the hands of a clock, okay? They rotate by the fixed point that joins those hands. All right, so a regular polygon has rotation symmetry, okay? Now, if the figure, okay, unlike the butterfly, has congruent sides and congruent angles, then it's a regular figure. So just be aware that a regular polygon, and I'm going to highlight this, okay? A regular polygon has congruent sides and angle measures. All right, so just be aware of that. So a square is a regular polygon because all four sides are the same length and all four angles are equal to each other, 90 degrees. So a regular polygon has rotational symmetry. That means it can rotate onto itself between 0 degrees and 360. It has rotational symmetry. It rotates onto itself at 360 degrees, then we don't say it has rotation symmetry because all figures have rotation symmetry. All right, so if you have a regular polygon, you don't have to count up the number of lines of symmetry. All you have to do is take 360 degrees and divide by the number of sides, okay? So that M stands for the angular rotation, okay? All right, so if it's a square, the angular rotation would be 360 divided by 4, which is 90 degrees. And then if I wanted the angles of rotation, it'd be 360 divided by 4, which is 90, times 2, which is 180, times 3, which is 270, and 90 times 4, which is 460. Okay, so it has 4 angles of rotation. This question is, what is the degree of rotation that will map a regular octagon onto itself? So it says regular, okay, which means all 8 sides of the octagon are equal and all angles are equal. All right, so with that said, this isn't working, sorry. All right, so regular means 8 congruent sides, 8 congruent angles in this instance, okay? So we don't have to use lines of symmetry. Since it's a regular polygon, octagon, to find the lines of angle rotation, it's going to equal 360 divided by the number of sides. All right, which is going to equal 360 divided by 8. Oops, sorry. Which equals, what's 360 divided by 8? 45 degrees, right? All right, if I want angles of rotation, if you were asked for angles of rotation at this figure onto it, then multiply 45 times 1, you back this up, times 2, sorry, we already multiplied, which is 90. 45 times 3, which is 135. 45 times 4, which is 180. 45 times 5, 225. 45 times 6, 270. 45. 45 times 7. Here we go. 45 times 7. And then 45 times 3. Those are all your angles of rotation. Okay? So if I ask for an angle, it's just 360 divided by the number of congruent sides. If I ask for angles of rotation, you'll have to take that answer and multiply it by 2 times 3 times 4 until you reach 360. All right. All right, so that should take care of that. Hopefully that helps you. All right. London uses geometry software to rotate the square about its center. Through which angle measures can you rotate? Okay, since it has 4 congruent sides, remember you can do 360 divided by the number of sides. If it wasn't congruent sides, you'd have to find your lines of symmetry and divide 360 by the number of lines of symmetry. For a regular polygon, find the angle of rotation by 360 divided by the number of sides. Okay? All right, so 360 divided by 4 equals 90 degrees. And just remember, you're going to have to multiply that into 2, angle of rotation. And then 90 times 3 is the third angle of rotation. And finally 90 times 4. Rotation 360 degrees. Once you hit 360, that's all the angles of rotation that are possible. We call this figure of square rotational symmetry because it has angles of rotation other than 360. All right, this is what your quiz will look like. Okay, you'll see symbols. And let me point it out. If you look at the very first one, it says rotation, switches the X and Y coordinates and changes the sign. Give me 1 second. Let's see if I can. All right. I want you to look at the symbol, how it's written symbolically. So a rotation, the capital R stands for rotation. You're gonna, if 2 sides of an angle are overlapping and one side stays stationary and the other ray of the angle moves counterclockwise 90 degrees. So it starts, the 2 rays are overlapping, that's an angle of 0 degrees, and then as the top ray or one ray moves counterclockwise, the angle is opening up and it rotates to 90 degrees total. So that's what that is saying. All you do is switch the X and the Y. So you're going to switch 7 and 9, if these are the 2 angles you're working with. You're going to switch them, and you're going to change the sign on the 9, or the first coordinate So you're going to change the sign on the first coordinate. 9 is now the first coordinate after you make the switch. Now, if you rotate 180 degrees, so this is saying a rotation of an angle. The angle starts off with 2 rays overlapping, so the angle between the rays is 0. But if I rotate counterclockwise 180 degrees, what happens? All you do is you don't switch this time. So no switching, okay? Notice the 90 degrees switches the X and the Y. Notice 270 will switch the X and Y. But there's no switching for 180. All you do is multiply the X and Y coordinates by -1. So let me just point out, I don't want to annotate anymore. Okay, give me 1 second. All right, so for 180, all you have to do is multiply the X and Y coordinates by -1. Okay? All right, and all right. All right, so 4 times 1 is -4. 5 times 1 is -5. It doesn't mean that the image coordinates are always going to be negative. It just means change the signs. So look at this second grid here, the coordinate plane. You have the point A, Q1. And you have this straight angle, A, O, A prime, or the rays start at the origin. Each side of the angle starts at the origin. Think of the side of an angle. This ruler, one end of it is fixed at 0, 0. The other end has A attached to it, point A. Imagine taping a point to the end of the ruler. So if I rotate counterclockwise onto A prime, okay, look at that angle formed whose vertex is at the origin. That's a straight angle. That's 180 degrees. In the first coordinate plane, look at the angle formed by the sides of the angle in the origin. That's a right angle in there. Does that make it that L shape? I know that because there's this little square near the vertex. I'm not sure if you can see that. And then lastly, your 270. What that switches just like the 90. But the 90 changes the sign on the first coordinate because it comes first. 90 comes first before 270. And then 270 changes, it switches 2 and 3, so it becomes 3, 2, but it changes the sign on the last coordinate. So 2 becomes negative because it isn't after switching, it's the last coordinate. So the way to remember is 180 doesn't switch the coordinates, doesn't switch X and Y, just multiply both coordinates by -1. Now 90 is the first angle of rotation, and if you switch the coordinates, you change the sign on the first coordinate because it's 90 degrees. It's the first angle of rotation of the 3 angles, 90 degrees. 270 is the last of the angles, okay, that we're studying here. And since it's the last, you're going to switch the coordinates. You're going to flip X and Y, the sign on the last coordinate. All right, so lastly, okay, last thing. All right, so with that said, let me erase some of this stuff. It's not erasing. Okay, so let's take the point 29. Oh, there it is. Okay. Why isn't it erasing? All right, kids, don't try this at home. It's not working. All right, what is wrong? I can't. See if this works. It's not working. All right, we'll just move on. All right, pretend that never happened. Okay, so if we have, let's go to the second problem here. If we have the point 3, -5, remember 90 and 180 switch the coordinates. So if we switch these coordinates, we're going to have 5, 3. But remember, since 90 is the first angle of rotation, it comes first before 180 and 70, we're going to change the sign on the first coordinate. So it becomes -5. And just remember that 180-degree rotation, okay, doesn't switch X and Y, so it still says 3 and 5. The only thing that changes is you multiply 3 times the -1 and you get -3. And then you multiply the Y coordinate by -5 times -1 is +5. Okay? So you don't flip-flop X and Y. All you do is take the opposite sign of X and Y. Or think of it as multiplying by -1. And then lastly, 270 is the last of our angles. So 90 and 270 are the ones that switch the X and Y coordinate. Since 270 is the second one, the last one, so I'm going to flip X and Y, so it's going to be -5. And it was 3, but since 3 is now last, it's the last one. All right, last thing we have is ticket out the door. Okay, Daniel's green carriage moved to the yellow carriage when it got stuck. So when you see start, it moved to that position, the yellow envelope. Okay, in order to get the Ferris wheel turning, the operator needs to enter how much the carriage has moved. Okay, so I'm talking about the angle of rotation. So how can we find it? Now remember, I wish I had a pointer. To go look at the side, start at the green gondola, draw a line segment. Notice the side of the angle from the green gondola to the center of the Ferris wheel, and then the other side of that angle from the center of the Ferris wheel to the yellow gondola. If you eyeball it, that angle appears to be 90 degrees. But are we going to use what we learned today? Sometimes we can't eyeball if the angle of rotation is 135, whatever. What we have to do is say, okay, we have 12 congruent rays or angles. We're going to divide it evenly. So we have 360 divided by 12, which is 30. So that's our first step, 360 divided by 12. Okay. So our angle of rotation, just one, all the sides are the same length, right? So it's a regular, and think of it as you think of a regular polygon, okay? We're going to do 360 divided by 12 gondolas. There's 12 chairs, there's 12 congruent angles. So that's going to be 30, okay? But how many angles that measure 30 does the gondola pass through before it hits the yellow gondola? So if you count from green to pink, that's a 30-degree angle. From pink to blue, that's a 30-degree angle. And from blue to yellow, that's a 30-degree angle. So remember what I said, when you get the angle of rotation, the figure can map onto itself. The angle of rotation times 2, times 3, times 4, times 5. Well, etc. All the way up to 360. So how many angles of 30 degrees does the green gondola pass through yellow? It's going to be 30 times 3 angles, and that's how we're getting our 90 degrees. Okay, that's it, folks. I just want to remind you one last thing. take a second attempt on quiz 107 and have a great day. Make sure all the work done. Thank you. Okay.